In this video, we're going to look at determining characteristics of a function from a graph. The first thing we're going to look at are what are called the zeros, or the roots, or the x-intercept of a function. This is where the graph of a function hits the x-axis. As we can see, it hits at 4 points, at -4, -2, 0, and 3. Now let's write these up in pairs. Now because the y-coordinate in all of them is 0, for instance at -4 it would be -4, 0. Then we'd have -2, 0, 0, 0, and 3, 0. So that's how we could write x-intercepts as ordered pairs. Next we're going to look at the increasing and decreasing behavior of a function. We read a graph from left to right, and if it goes down it's decreasing, if it goes up it's increasing. So what we're going to do is we're going to cut the graph off where there's turning points. Notice that the graph starts out at decreasing, but then at about -3.1 it switches and goes to increasing. Then it increases up to about -1, where it stops again and changes directions back to decreasing right about to 2. We'll just estimate it at 2 for this problem. Now, to write the intervals where it's increasing and decreasing, we used what's called interval notation. It looks a lot like the ordered pair form of a point, but we're actually doing intervals of x values only. So this first place where it's decreasing, well, it comes in from -infinity and decreases till about -3.1. Then, as we said before, it switches to increasing from about -3.1 to -1. Then we see it switches again back to decreasing from -1 to 2. Finally, our last interval, it increases the rest of the way, so we'd put it as 2 to infinity. Now, what we're going to do, we have 2 places where it was increasing and 2 where it was decreasing. We need to group those together. So there's our 2 places where it was decreasing, and then we have 2 places where it was increasing. So in writing this up, what we're going to do is we're going to union those 2 distinct intervals together. So it's increasing from -3.1 to -1, and also from 2 to infinity. It's decreasing from -infinity to -3.1, and also from -1 to 2. Notice in both cases the order goes from left to right, or this most negative number to the most positive number. We always go in that order. The last characteristic we're going to look at in this video is concavity. There are 2 types of concavity. There's concave up and concave down. So function is concave up if it opens upwards. So looking at our function, the first place where it's concave up is that first part from -infinity up to about -2.1. Right there it switches concavity. So it switches concavity and is now concave down to about just short of 1, so we'll say 0.9. And finally the rest is concave up. Now just like with increasing and decreasing, we're going to use interval notation. So it's concave up from -infinity to -2.1. Then it switches to concave down from -2.1 to 0.9. Then it switches back to concave up from 0.9 on to infinity. So we have 2 places where it's concave up and 1 where it's concave down. Now we will write this up in interval notation, and we're going to group the 2 that are concave up together just like we did before, and we'll union those together with a u. So from -infinity to -2.1 and from 0.9 to infinity it's concave up. From -2.1 to 0.9 it's concave down. Now this is important because where a function is concave up it has an increasing rate of change, and where a function is concave down it has a decreasing rate of change. So just as a recap, here's our original function. We found that it had zeros at -4, 0, -2, 0, 0, 0, and 3, 0. It was increasing from -3.1 to -1 and 2 to infinity, decreasing from -infinity to -3.1 and -1 to 2, concave up from -infinity to -2.1 and 0.9 to infinity, and concave down from -2.1 to 1.9. And that's how we can identify some of these characteristics from a graph.